Right, so this is lesson 4 in the graphing unit, maybe arguably the most important lesson in this unit, critiquing graphs and identifying misrepresented data. Often in the media or just in any real world example, graphs are not always done correctly, and sometimes data can be distorted, and if you're not careful, you can be persuaded to interpret the results of a graph incorrectly just by how it's drawn. So we're going to look at some ways that the creator of the graph can maybe distort the results and make them look a certain way just by changing how they make the graph. So it's not that they're graphing the data points incorrectly, it's just that they're using some strategies to distort the results. So let's look at the first example here with trends over time. So these are line graphs, and we're looking at graph prices over time. They're the exact same. This is the exact same data set. So on the left, we have cost of gas over time per year, and same thing on the right. So the exact same data set. Just take a second and see what you notice about just the patterns in the picture itself when you look at both data sets. Okay, so there's nothing wrong with how they've presented. I'm just going to zoom in a little bit closer to these results so that we can look at them better. Now, there's nothing wrong with how they've presented the data here, really. Like for both of them, they've chosen a scale that starts at 0 and goes up by a consistent amount. However, in this first graph, they've only really used a very small section of the grid to show the data. And that makes it harder to see trends, and it makes it harder to look at details, right? Whereas in the second graph, they've chosen to go up by 0.25 instead of 0.5. And we're using a much bigger portion of the grid. And in this case, we can see details a lot better. So let's look at, it says, what's the same and what's the difference? So what's the same is the data set. The title's the same, the labels are same. Different is the scale on the y-axis, the vertical axis, right? On the first data set, we're going up by 0.5 and the second one, 0.25. So B, what type of people might prefer to use each graph? So when we look at data set A, I'll just call it A, the one on the left, you might want to use that data set if you want to prove to people, or you might want to, if you have the narrative like, oh, gas prices haven't increased that much, the changes haven't been that big. Whereas if you wanted to say that the changes have been really big and dramatic, you might want to use the one on the right because the changes look more extreme, even though they're the exact same changes in prices. So if you want to use the one on the left, you might want to change, if you're wanting to show that the changes in prices haven't been very large, you would want to use the one on the right if you wanted to make the conclusion that there has been big changes. So by squishing your data into a small section of the grid, you kind of downplay any changes in the data because they're just hard to see when you're squishing it all into a few grid lines. Okay, here's another example. It says, below, the graphs display data about how many full-time Canadians have a job from year to year. The graph on the left has a break in the y-axis and the graph on the right does not. Okay, so again, we're seeing the same data set. Okay, so exact same data. So a break in the graph is when you jump. So we're going from 0 here, and then this little break means we've jumped all the numbers from 0 to 42, and then we just started going up by 1. Sometimes you want to use a break if it's practical, but you just have to realize what the break does to the picture. On the right, we haven't used a break. So it just goes 0, 10, 20, 30, 40, 50, 60. So if you wanted to, so this is the exact same data set. So when you have a break, any changes that occur are going to be so much more extreme. Whereas in reality, the percentage of full-time Canadian students with a job has been pretty consistent, always between about 42 and 46.5% or so. But when you have that break in the graph, it looks like it's jumped to such an extreme value over time, but really the change has not been that big. Okay, so let's answer the question. It says, which graph shows a more accurate representation of the data? The graph on the right is more accurate. The graph on the left makes the change look extreme. Someone who just glanced at the graph and didn't actually read the numbers would think, whoa, so many more Canadians are having a job. But actually that's not true. The actual change has not been that much. A break in the y-axis can cause small changes to look larger. Okay. All right. So let's look at the next example. We're looking at some bar graphs. So let's look at the data. So this data is showing the percentage of First Nations children who take part in traditional singing, drumming, or dancing groups during school hours. Okay, so this is not a great graph because we don't have labels, we don't have a title, right? So it's children who are taking part in traditional activities. But there's something else that's wrong with this graph that makes it hard to read and understand. Just have a look at it and see if you can predict what I'm going to say. So we have never, less than once, 1 to 3 times a week, and then greater than 3 times. Now the problem with this bar graph is that the bars are different widths. So it makes it harder to compare. It makes it look like, even though like a lot of students are never doing the traditional activities, because that bar is so thin and these bars are wider, it looks like maybe that bar is less important. It just makes it harder to compare. Okay, so let's answer the questions here about this graph. How is this graph misleading? So there's 3 things that make it misleading. The bars are different widths. So for a pictograph or a bar graph, you should always have the same size. So same width of your bars or same size of your pictures. That way it's easier to compare. There's no label on the y-axis. Should say percentage of children, and there's no title. Okay? So we don't know what's being portrayed here. What other information could be added to the graph to make it better? Okay, label and title. Also, there is no like total number of children. So we're showing the percentage with the number of children that were surveyed. We talked about that in the circle graph lesson. It's good to include the total in your title, especially if you're showing percentages. What other type of graph could be used? We could use a pictograph here. We could also use a circle graph because this is a percentage of a whole. So a circle graph would be good because it's showing categories and percent of a whole. Okay. All right. That is the end of the lesson.